Bonjour à toutes, bonjour à tous. Merci de nous retrouver pour cette deuxième après-midi de l'AFMEX. Merci à vous de votre fidélité. J'espère que nombre d'entre vous étaient déjà là hier et que vous allez vouloir poursuivre cette seconde demi-journée avec autant de passion et autant d'échanges. Donc au programme cet après-midi, nous avons l'intervention de TS Agro, qui est une entreprise danoise qui vient nous présenter son parc de matériel, suivi de l'intervention pour l'entreprise Wintersteiger de Damien Marquilly. Ensuite, nous aurons l'entreprise Aldrup avec Gilles Beaufils qui interviendra, suivi de Harald Albert pour la société Zurn Harvesting, et ensuite Dorian Blo pour Agristructure. Tout de suite, je vais donner la parole à Morten Nigar. For the rest of this webinar, this is Morgan Nigar, Danish company, TS Agro. He will be presenting precision plot and new generation of semi-autonomous tool carrier and many other tools. You can start. You can start, Morten.
You see the presentation now?
Yes, we see it.
So thank you, first of all, thank you for being able to join the AFMEX conference and for the introduction by Dorian. And yes, I am here to present, just need to get it into technical solution for AgroScience, a Danish company which is providing field trial equipment. This is our specialty and what we actually do. And I am going to share the portfolio which we have put together, calling it Precision Plot. Precision Plot contains a plot seeding unit. It contains a plot sprayer to come. I will end up presenting that. And we also operate with plot fertilization. Additional in the work we're doing, we are looking into yield estimation by camera together with harvest eye as an example. So our tool carrier. So implementation of autonomy in field science. So why does it matter? Well, we are all being told to act more efficiently. And normally I would say we cannot run faster, but we can run more efficiently. And here we need to implement technology. So normally a seeding platform contains the staff of 2, but by implementation autonomy in here, we can actually reduce that. Nordic has a widespread scarcity of labor, and I see it as an increasing issue in Europe. Safety and environmental social governance is also something which is on high agenda in the Nordic and something which is rising. And implementation of automation actually reduce static workflows. We are also very heavily looking into lifting functions on machinery to avoid them and to avoid exposure and hereby support sustainability goal. We have as an example a tip over bar, which I'll show you later on. So innovation, well, the carrier gives you the opportunity to design your own machine. So define your task and what you need to execute, and you can implement the tools on the carrier. Of course, we need to provide the implementation of GPS for accuracy and also for data logging, and this is implemented. The capabilities of the platform is either 2 or 4-wheel driven, and a key element is trailer transportable. And it's suitable for various crop seeding, including single seed. I will show you that later on. We can operate in minimum tillage and plow system. We can implement a row cleaner, row sprayer. We could operate soil sampling. So it's just about your imagination. So It's a tool carrier. It's a platform designed for field applied science. This is what we actually call precision plot. So as a starting point, the carrier became a plot seeding unit for variety and fertilizer testing. We have now proof of concept. We have a unit which is now operated by one scientist. We have been by our competitors called first of its kind. It is acting on high accuracy based on implementation of GPS controlling. We operate with plot length from 3 to 12 meters, depending on needs. We have a plot width of 1.25. And on this version, we have integrated Sparkle from Harvest Master for seeding control. And we are operating with GPS RTK from AgLeader. The concept was delivered in March 25, so close to a year ago. So it has a spring season and an autumn season where the customer is expressing high satisfaction, and therefore we now consider it as a proven concept. When you go closer to it, from the seeding platform on your left side, you have access to, in this case, 2 belted cones. You have access to a seeding box. We have, from, again, work environment perspective, we have implemented a elevator. So seeding boxes, we all know the weight of a seeding box full of bagged seed. It's heavy, and now we can actually elevate it from ground level to the seeding platform. When not used, it's easy to fold and thereby not be in conflict of any other operations. On your right, you see the toolbar, including a roof. This toolbar can be folded on the back of the machine and thereby going into transport mode. So transportation is a standard trailer. So this improves the agility, meaning you have a larger operation radius, so you can actually define the target and go for that specific field you need. It has an actual weight of 2,300 kilos, so it fits behind a standard car. More details. So center wheel is 150. We have an axle distance of 3. The fertilization application for granules is, in this case, Rotec disc, 5 rows with a 25 centimeter distance. You can adjust the seeding depth independently from the seeding units. The seeding units, we are using gravity. This means no air for seeding cereals, canola beans, peas, grass. We have implemented TwinTech from Amazon with a 12.5 centimeter distance. Again, you can adjust the seeding units independently from the fertilizer disc. In the center, you can actually see that you can also seed grass with this setup. We have mounted, in this case, 2 belted cones. So, from a fertilizer perspective, we have a seeding box and a cone planter. So this means that we have 2 entries to the fertilizer disc, and we have 1 entry into the disc for seeding. The seeder platform has 1 seed in driving direction. We are utilizing GPS for the cone planter, and we have a encoder, so pulses for speed. And we are, as said, utilizing Sparkle from Harvest Master to control the cone. Seeding depth, easy to adjust, simple operational maneuvers. So in the front of a traditional seeding platform, you will have a driver function. But in this case, we don't have the driver, but instead we have provided a safe and easy access to the seeding box. So again, avoiding heavy lifting, climbing on top of machines. here we have simple, easy access to a seeding box, which is simple in its construction, easily to calibrate. It's electric control, which means that you can actually enter multiple rates, which you easily can shift between. So maintenance while seeding is hereby an option provided here. So some of the ideas which we are currently working on with our tool carrier is to implement single seeding units, which will be able to seed a wide range of crop from canola to until beans, with a row distance of 16.5 to 20 centimeters, depending on the seeding units which we are utilizing. Again, we are still able to mount fertilizer disc, and we could also provide fertilization by liquid, as we have a compressing unit, so hereby compressed air on the platform. Single seeding is a collaboration between Kramerstad in Holland, or the Netherlands, and TSA. You see a drawing of the platform on your right side. So design and data management. Well, you can work from ARM, Excel, etc., just as providing it with a CSV file, so we can push the design to the platform and we can seek based on that, either Sparko or FieldPro from Kramer. The FieldPro actually has a barcode solution, so that we can, in 2026, we will implement the ability to scan your bagged seed prior to seeding. The Kramer system also provides a documentation of seed counts. So the single seeding unit is actually able to count the seed which is going through. And there's a camera installed as well, so you can monitor the flow. Some of the future ideas is to mount camera technology for multiple purposes on the same unit. Now to the second platform, which is in the design phase, is in the demand specification phase, and it's a semi-autonomous tool carrier for plot spraying. And here I ask you to join me in a mission. And my mission is that I want to remove the scientist for doing what's in the picture. And you can say why, what, and how. I have a history of 15 years within Dow AgroSciences, so I have a large stack of biological assessment dossiers behind me, and therefore I do actually have the knowledge behind that. A majority of data which is being generated for dossiers and thereby supporting product registrations is normally based on a nozzle type of 0.15 to 0.3, a 200 liters of water per hectare, a approx speed and a boom height, etc., and often it is either a bicycle or a boom carried by a scientist. I'm saying if we are to take sustainability and environmental social governance seriously, we need to change that. And I will provide you with an idea which we are currently working on within the company. And my view is to offer attractive working environment for our field scientists. And hereby I'm saying we need to remove our scientists from the contaminated area. I hope to give you an overview and idea of what we want to achieve. This is a draft design, so it's not final at all. It is just taken straight out of the internet, but it illustrates what we would like to achieve. You can all see, if you have been working with field applied science, that this is a carrier. What is missing is the boom section. So I'm saying we are to provide the 21st first and hereby the next generation of future plot sprayers. So it's not only me or TS Agro. No, I have a production site called Fidan Engineering. We have a Danish company called Danfoil, which is farm sprayer production, which also has the ability of injection. We are working with Ag Precision, a company which is provider of GPS by Ag Leader, and we have a Danish, another startup company working with a vision system. They are called PearPlant. The structure of this project is put into 4 work packages. So it's starting, we will be working on a graphical user interface. I will give you an overview later. So we need a unit for controlling the semi-autonomous sprayer. I want to implement injection. And why is that? Because I want to work with close system for pesticides handling and hereby safe operation with pesticides. Secondly, I want to achieve that we can actually do up to 24 different treatments without pre-mixing. Another element is application technology. As I said, we are utilizing low drift flat fan nozzle for the majority of our trials. If you go to the farm sprayer, they are far more advanced in application technology. They will go air assisted, they will go angled nozzles, they will work with all kinds of technology. And basically one of the ideas with this project is also to give the path forward for a reduction of either pesticides or fertilization by implementation of application technology. And the trial platform will be a platform for testing each of the technologies independently. And the last package will create a autonomous tool carrier. So funding and development strategy. Well, the first contract research organization, it's a Swedish organization in the southern part of Sweden. They agreed to join, and we has also achieved public funding in Denmark, and we are actively still seeking co-development partners for the project. This is me trying to give you a visual overview of what we are trying to achieve. As you can see in the left side of the slide, we have a dotted line. On the left side, you have a scientist in the safe area, in the area where we do not apply pesticides, whereas the sprayer are the one going into the contaminated area of the field. The scientist will have a full control and view on all operations while the sprayer is operating. One of the elements is implementation of a 360-degree camera, but there will also be other monitoring elements in the control module system for controlling the tool carrier. The carrier will be electrified. The seeder which I presented to you was driven by a diesel Kubota engine, but here we want to work with electricity because we want to reduce weight. We have a target that the carrier should not exceed 750 kilos, because we also have an experience that motorized plot sprayers or tool carriers often becomes too heavy and thereby are not able to operate in the wet autumn or early spring. So therefore, weight is a key element to us. We will operate with a water tank of clean water. We will have an injection platform where we will be able to implement up till 10 different plant protection products, and we will inject into the system based on that. So it means no premixes, no leftovers. We are only to use the exact amount which needs to be available for our specific treatment. We will have a dual boom section, so a air assisted boom, but also a conventional boom, So again, that we are able to test different technology against each other. So this is the vision and this is the mission that we want to accomplish. So summarized, well, working environment, actually the machine directive within EU is under revision, and it says that all hazards should be applied from a cabin, or there is an or, and that or is to be wearing specific protective clothing. But I'm getting more and more feedbacks from field scientists that they do not want to sit on a sprayer or walk behind a boom to apply pesticides. And I can understand the reasoning why. So from a sustainability perspective, well, in my view, we need to move to a different direction. Secondly, heavy lifting is also something which we need to avoid. And efficiency, well, the automation will give that in field trial execution. Clearly, from a safety and pollution perspective, removing the scientist out of contaminated area is very clear. Secondly, the injection system to work in closed systems with pesticides, not being able or not have to clean containers, clean systems, etc., is also avoid and hereby that the scientists will not be exposed to pesticides. Allocation, well, of course, human capital is reduced, as often field applied science includes 2 scientists, and this platform is to be operated by only 1. So net zero carbon neutrality goals, oil-based systems, so hydraulic oil-based system, the energy loss is actually 30 to 40% from the applied energy, whereas a electrified solution is far more efficient and is providing a 96-98% efficiency. Then you can ask yourself, so why didn't we implement a battery solution? We are to produce the electricity on the platform because batteries are too heavy. But we have already, you can say, considered a implementation of batteries, but we need to await that they will become more light and more efficient. To implement and to be able to do 24 treatments in a 4-replicated trial exceeds by far any other spraying platform and hereby increases efficiency significantly. So we started in February last year with an application. We got funding in August and the project is ongoing. We are doing the demand specification. All the initial starting is ongoing, and we expect to have a prototype for field testing in autumn of 2026. And we have a platform targeted as available for March 27. So thank you. Sorry for my French. I would have loved to be able to speak your wonderful language, but unfortunately I am not able. But I hope that you will support the mission and join this project. So thank you so much.
Thank you. Thank you. Thank you for your contribution. We understand that precision plot in the first part of your contribution, your precision plot is not just a simple tool carrier. I think it's a response to the current challenge of experimentation, I think. And thank you for your presenting your prototype project. I think it's really interesting. Thank you, thank you. Morten, you are of course welcome on the equipment show in January, on the 21 January on 2027. If you want to come, it's all right for us.
I have already blocked the calendar.
Okay, Thank you.
I will be
Thank you.
there.
Thank you. Thank you. Eh bien, écoutez, merci Morten. Nous allons pouvoir continuer la suite de nos interventions.